Hello, welcome to my virtual poster. I'm going to give you a quick run through, as quick as I can. If you have any additional questions, please get in contact via email or Twitter or whatever you like. So, my poster is called Detail and Spatiotemporal Structure in Naturalistic Recall. Now, in this project, I wanted to bring together two different hallmark measures of episodic memory from different literatures. So on the one hand, we have measures of temporal contextual organization from the laboratory or word list recall literature, also the rodent and computational modeling literature. In these literatures, there are very powerful methods for measuring temporal organization and episodic memory as measured by the kinds of recall transitions people spontaneously make. So we're looking at recall dynamics. Now, on the other hand, we have autobiographical memory, so our rich real-world personal experiences, which are populated by all kinds of episode-specific information, so sights and sounds and smells. But in these studies, we usually can't measure recall dynamics, or we can't relate recall dynamics back to the original event dynamics because we didn't have control over the original event. So we don't know the order in which events unfolded. So I wanted to bring these two approaches and these two measures together and look at dynamics and details in single real-world memories. I wanted to ask if both of these aspects of memory decline in older age, as has been found in separate literatures. And I wanted to ask the more interesting question, I think, are more temporally structured memories richer in episodic detail? So this has been hypothesized going back to Tulving, and we know there are neurophysiological connections between temporal organization and vivid, detailed re-experiencing, but I don't think these two ideas have been put together in a convincing way. So in two studies, participants underwent controlled real-world encoding experiences. So these were audio-guided art tours of an actual hospital, Baycrest Hospital, which is a Jewish geriatric hospital in North Toronto. Baycrest has a surprisingly interesting art collection, so it's full of this unusual, interesting-looking stuff. Now, in Baycrest Tour 1.0, we had a younger and an older adult sample, and they performed free recall at a 2-day delay. Now, we had a totally separate tour on a totally different floor, Baycrest Tour 2.0, and here people performed recall at a 1-week delay. These were only younger adults, and we had a much bigger sample, so almost 80 people here. Now, roughly what we did is we took these free recall narratives, so people spontaneously told us everything they could remember about the tour without any constraints. And to measure temporal organization, we noted each mention of the target items in the tours. So these are items to which the audio guide cued people's attention. So we know everyone encoded these things and encoded them in the same order. And we could submit these vectors of time tags to powerful measures of temporal organization derived from the word list learning literature. To measure details, we use the autobiographical interview, which separates episodic from non-episodic content. So we call the episodic stuff internal details, the non-episodic stuff external details. What do we find? We found that spatiotemporal context significantly guided real-world recall dynamics. So the hallmark measure of temporal organization and free recall, I think, is the lag conditional response probability curve. So this shows the probability of transitioning from one item to another conditional on their lag, so their distance and their order based on the encoded distance and order. And you can see that participants in all groups have these peaks around 0, suggesting that they're making recall transitions that are close in space and time. And there's this really strong forward asymmetry, so people are tending to recall in a forward direction. The older adults seem to do this less than younger adults. So I pulled out temporal clustering and forward asymmetry separately to look at them a little bit more closely. So to measure clustering, I used the temporal factor from a computational model from Sean Paulin in 2009. Basically, we're quantifying temporal clustering here. When I say temporal, of course, in these studies, that means spatial too, because what's closer in time is also closer in space. The short story is that all participants show above chance temporal clustering, but we have a very strong age effect where older adults' memories exhibit significantly less clustering. Keep in mind, all these measures control for the number of items recalled, just isolating the dynamics of the items that are recalled. Now moving over here to forward asymmetry, this is simply the proportion of all recall transitions that move forward in time. We see the same pattern. People's memories are very forward asymmetric, but older adults have reduced forward asymmetry, so they're more likely to jump backward in time and space than younger adults. Now, the bigger question here was, how do these measures of temporal organization relate to the content of memory, to the kinds of details people recall? So I ran some mixed effects models. Briefly, I was predicting detail count from detail type and from temporal clustering. And you can see that higher temporal clustering was associated with more internal details, so more episodic stuff, and less or fewer external details. But you can see it's really driven by this increase in internal details. There were no interactions with groups, so I'm collapsing across groups here. And to really get at the hallmark measure of episodic detail richness, we took the proportion of all details that were internal. We found that more temporally clustered memories were more episodically detail rich. This holds when controlling for the number of items people recall too. Now, I did the same thing with forward asymmetry. It's a similar story here, except forward asymmetry was not related to internal detail count, but was negatively related to external detail count. So the more people recalled in forward chronological fashion, the better they were at suppressing non-episodic details. And lastly, I wanted to visually relate these two hallmarks of episodic memory, so the lag CRP curve for temporal organization and the internal to total detail ratio for detail richness, the kind of details that inform our ability to re-experience past events. And basically, I binned all participants into internal detail quintiles. And you can see that these quintiles line up in gradient-like fashion at the critical lag +1 position, meaning that memories that are more dense in event-specific details are more likely to have these forward-going sort of tight spatiotemporally constrained transitions. Okay, so in brief, we found that principles of temporal organization from wordless learning studies generalized to real-world events after days or a week, and this has consequences for our understanding of temporal organization. It can't be based on recency, rehearsal, or strategy. These are one-shot events. Aging was associated with pretty strong declines in temporal context reinstatement, controlling for non-temporal features, which I didn't report here, namely serial position curves and recall initiation, which are not different across younger and older adults. And I think the more interesting big picture conclusion here is that the way we move through memory space, the trajectory that we take through an event, shapes, or at least is related to, the quantities and the types of details that come to mind. So I think we've made some progress in uniting these two different aspects of episodic memory, both of which were included in Endel Tulving's original definition of episodic memory. So thank you for coming by. Please enjoy the rest of the conference and stay healthy and comfortable.